good morning. Today is an exciting day. It's not only because we have a cat with us, but also because starting work on a new semi-side project sort of thing, which I have actually started work on before. It was probably like 6 weeks ago or so when I first showed the initial sketches of what I'm going to show today. But I have finally decided to pull the trigger and actually commit to working on the Butler / primer / whatever we want to call it, launcher. And yeah, I'm very keen to get into it. I've been thinking about doing this for quite a long time, and it's a tricky decision to make to do this, because I think that this, for context here, what I want to make here is the immediate outcome of this little side quest is going to be to have a little robot that will sit on top of the shelf just behind me over there that will throw balls into Jugglebot, and it will have a little hopper with it so I can load it up with however many balls I've got, and then it will just be able to throw the new balls into Jugglebot as Jugglebot needs them. The longer term goal of this is that I want to have a robot that will basically do the same thing, but for me, when I am juggling at the park, because I absolutely despise having to bend over and pick up balls every single time I drop, which when you're practicing like 5 to 7 balls, if you drop one, you've probably dropped a few, and when you're throwing them that high, they tend to just scatter everywhere, and it's so frustrating. It really just like takes you out of the zone. Yep. And yes, I'm expecting both of these things to take quite some time. I will probably not get to the point of having it work for me in this, session, I guess, in this little instance of the side quest, but I intend on having this at least reach the point where Jugglebot can use it. So it will be on top of a little shelf over there. There'll be a little tray or hopper of some kind for the balls to be loaded in, so I can just put all of them in at once, and then it will be able to throw them out one at a time to Jugglebot precisely and in the right time and everything. And yes, I am expecting this to take quite some time, so it's tricky to know when to pull the trigger to do this, because this is going to obviously take time away from me working on the main project itself, being Jugglebot. And really, I don't need this right now for Jugglebot, because like Jugglebot's only just really started getting to the point where it's throwing balls by itself, kind of like in a more targeted way than what it was doing before. So we're only really kind of just beginning the Jugglebot's dropping adventures, I guess. But even with just this, it's still been pretty annoying for me having to like walk around the floor fishing up all the balls, because right now I only have 5 that Jugglebot can use that have the tracking stuff on them. And yeah, I don't like having to constantly be reloading it manually myself every time. And that's with this having just begun. So it was a lot of umming and ahhing about whether or not I should do this now or if I should wait until later on when it's a bit more important for Jugglebot. But there are a couple other things that I hope to gain from doing this that I think will make it worthwhile doing now rather than waiting for a bit later. And I'll get into those as we go. I think it'll make more sense to explain them with the model in view, so you can see exactly what I mean. There are, however, this is a bit of a So the reason why the thumbnail is a different color is because that will be the color of the Butler project, or the ball primer, or whatever we're going to call it. So I'm intending to have all updates and like main videos and whatever else that we make on the Butler will have this blue background, so it'll be really easy to see what's what when we're looking back through later. That's the intention, at least. I don't know, let me know what you think, if you have any thoughts. And also this week I don't have a PowerPoint because I just want to I want to talk through the model with you. But before we get to the model, I actually have some cool things that I want to share with you. So I've been watching a couple FunctionalPrintFriday videos whose channel I should have linked in the description, and I'll put a link in when the stream ends, but I forgot to before we started. And I like the format of his videos. If you haven't seen them, I would recommend checking them out. Some of them are a bit long, but I guess I can't really talk. And but the idea is interesting. So he goes through having like a problem and then an interesting way that he solved that with a printed thing. And he's coming up with some very cool things, like these bellows that I have now retried printing and have like a proper thickness on, and they kind of work. I want to do a little bit more testing with this, but yeah. And this is an idea that he had. So this is like TPU laid through, and then you print this with PLA like sheets in between to support it all properly, and then when it's done you just remove the PLA and you have a bellows. Very, very cool idea. So in the spirit of his kind of videos, I wanted to share with you two things that I have discovered in the last couple of weeks that I found to be very, very interesting, and I think you may as well. The first is that this is 3D printed, this net. So hopefully this is kind of coming up on the screen. I can like mush this around to be like a tiny little ball, and then poop, it just pops back out to be a full mesh. How cool is that? This is printed out of TPU. When you print it out of PLA, I've got one here that has like a leaf in it. It's a lot less flexible, as you would expect. And yeah, when I did this, the color matching didn't really bond very nicely together. So these kind of like separate a bit. But yeah, super, super cool. There's a link in the description for the Maker World project where I first found this. And I've also made a feature script on Onshape that will allow you to meshify whatever object you want, if you are patient. Because I am new to FeatureScript, and my FeatureScript is not efficient at all. Let me just show you what this looks like. Here we are. So the way that this works is we can set essentially what this is doing is we've got like a layer of lines going horizontally and then a layer of lines going vertically, or whichever way you want to look at it. And it's just 2 layers thick, and then yeah, it makes this nice mesh. On the original one, I don't have a border on here. Like on the one on Maker World, there's no border around the outside, but I think a border, I don't know, kind of works nicely to tie it together. And yeah, in my feature script, you can set how thick you want the border to be, how many layers you want. The thickness of the mesh lines themselves, so like how dense you want the mesh to be, how far apart you want the lines to be, and then how much overlap you want between the mesh and the border if you want to try printing those two in different materials. Yes, this does take a long time to generate though. This one by itself is 7 seconds just for this model. For this tree thing, this was 45 seconds, meshifying both of them. So if you want to check it out, I recommend go for it, try it, but if you know anything about FeatureScript, you might want to muck around with it yourself to optimize it a bit. It's very, very, very not optimal, but it works. And with this, I have printed a little fan cover for one of Jugglebot's fans, because previously I was covering this fan. Let me show you what this spot is. Previously I was covering this fan with a piece of like fly screen that was doubled over just to make it a bit more dense, but that slowly became a bit dislodged and is now touching the fan, and it's making this really not pleasant sound. But now I haven't updated the model in here, but this is going over here. So this piece will fit perfectly. It should fit perfectly. I haven't actually put it on yet. Should fit perfectly over here to stop dust and everything from getting into this box, which would be pretty nice. And yeah, it's super cool. I definitely recommend checking it out. It's such an interesting idea for printing that I have never thought of before. And so obvious as well. Like, yeah, so good. The next quick thing that I want to show you is a shameless plug of a little indicator thing that I made, which you can use to select different things. So I have this on my AMS. So if I forget, because I always do, I always forget what filaments I have loaded in there, like what materials they are. So I can slide this to be whatever material I want it to be. And this is for the new AMS HT that will come out soon. So yeah, there's a model in the description. There's a link in the description for everything you need to make those. Cool. Okay. So yeah, I thought you just might find those interesting. If not, then yeah, skip ahead. All right, so let's get into the ball Butler model. As you may have seen from the thumbnail, the model is fairly based on the... I'm trying to like kind of borrow as much as I can from Jugglebot to this so that I don't have to like redesign things where I don't need to. But also because it's a very different objective, things do need to be redesigned a little bit. So I want to start with the hand aspect of it and then kind of work my way out. And keep in mind here that, the goal of this robot is to be able to throw to basically any spot around it in a circle of whatever diameter we want, like, I don't know, 1.5 meters-ish. So it should be able to throw to 1.5 meters away from it with, fairly good precision, and it should be able to access that whole space. So it will need 3 degrees of freedom to be able to throw to any spot, as far as I can tell. Yes, so I want to start with the hand first, and then I'm going to kind of work my way out to try to explain this. Yeah, I've got a lot of thoughts on this, but we'll get there when we get there. So yeah, the first part is the hand, and you can see this is extremely based on the hand that we currently have on Jugglebot, where there's an aluminium extrusion, a linear rail, the hand itself slides along that linear rail, there's a little motor, it's going to be the exact same motor, will actuate the hand to slide it up and down. There's a tensioning mechanism on the top, so this is currently mated in, so I can't really show it very easily, but if we do this, we can see, let's keep going to 90. We can see how this works here. So this is the exact same mechanism that's on Jugglebot's hand right now, where if we want this string to be a bit tighter, then we can loosen up these bolts that go into T-nuts on the aluminium extrusion, loosen up this bolt to raise it out, and then that will push this whole section out. Then we can retension these bolts on the side, and that will lock the whole thing in. So by doing that, that will basically raise this red part up and increase the tension on the strings. Other than that, it's very similar. So the main difference between this hand and Jugglebot's hand is how long it is, and also the attachment down the bottom. Down the bottom, for reasons that will become clear shortly, I was not able to... I couldn't figure out a neat way to include that same tensioning mechanism down here. So what I've done instead is this red part will be permanently fixed to the aluminium extrusion. That's never going to be adjusted. So to adjust the tension on the bottom side of the string, which is important, and I'll get to that in a sec, to adjust the tension on there, the way that's going to have to be done is by moving the motor itself up. So if we need a bit more tension down the bottom, then I can loosen up these bolts in here and the equivalent to on the other side, lift that whole motor up a bit, and tension that line. Of course, that will mean that I'll have to retension the top as well by the same amount, but I think that that's, I don't know, a necessary evil. Now, the reason why we need to tension the top and the bottom separately is because if I use the same method that we have been using on the hand so far, which I'm inclined to do because we know that it works, that method has the string actually fixed to the spool here. So it's like fully locked on, tied on. So it's basically as though there's 2 separate strings. There's one up the top and one down the bottom, and that's it. So if this were like a true Capstan style design where the string was just like wrapped around the spool a bunch of times, then we could, I believe, we could get away with just a tensioning mechanism on one end. However, then we introduce the possibility for the string to slip on the spool, and that's going to be kind of annoying. I don't really want to introduce that possibility, especially because of how high the accelerations are on this hand. And those accelerations are like even heightened by how small this hand is. Now, to figure out how short I could make this hand, because I want this whole thing to be as small as possible. Ideally, this, like, in an ideal world, the thing that I use for me to be able to return the balls to me when I'm juggling in the park would be like this. I want it to be as small as it possibly can be, because I'm going to have to carry it around with me, right? So I want it to be absolutely tiny. But it can't be infinitely small, because otherwise it's not going to be able to throw the ball. So to figure out how tall or how long I could afford to make this, or how short I could afford to make this, I just did some testing on Jugglebot, where I gave it an artificial limit of how, like, I basically told it, hey, your hand stroke, rather than being 360 millimeters, is now 160 millimeters or 260. And I just kind of played around and like tried it on the actual physical robot and just saw how well it went. And The biggest thing that was limiting how high it could throw is the current limit that I was allowing the motor to draw from the O drive. And I don't, this is the first time that I've really kind of pushed these boundaries. Normally I've just set a limit like 100 amps, say, where I'm like, that feels like a lot. And I just set that limit and then I haven't hit it, so I haven't worried about it. But now, because I really want to make this as small as possible, I kind of do want to be pushing that current limit a bit. And yeah, so I basically just tried throwing, and then I could see if the timing was wrong. Like if the ball was not going as high as it was supposed to, then the ball would land in the hand way before the hand went down to catch. Oh, my cat is screaming at me. Come on, get out of here. He's a bit fussy sometimes. Yeah, so I would basically tell it to throw with like a throw velocity of like 4 meters per second or whatever it was. And then if the ball was landing in the hand way before the hand was moving down, then I know that the hand did not actually throw as high as it was supposed to throw. So then I would increase the current limit to allow it to accelerate even harder and decelerate even harder until eventually it would throw and catch nice and smooth. I ended up pushing that to a soft current limit of 100 amps and a hard limit of 120 amps. And I didn't really feel too comfortable going further than that because those numbers seem pretty big to me and I don't really want to break anything on the physical robot. It wasn't quite able to throw to like 1.5 meters high, but it was getting just over 1 meter. So that means that if I have it on the ground, it will be able to throw up to a point where I can still catch it. And of course, a meter, if it's on top of that shelf there, a meter throw height is going to be very close to hitting the roof. So it doesn't really need to be able to throw higher than that for the purposes of throwing to Jugglebot. So I feel pretty good that this length is, and that was with this length of hand. So I feel pretty good that this will work. One thing that I just want to raise as a thing to keep in mind for in the future is that I did notice that when I was really pushing this to throw as high as it could in this short length, the hand was like really overshooting its target position before coming back down, which is fine on Jugglebot because it does have the space to do that. But on this setup, it will not have the space to do that. So that if I leave everything as it is right now, the hand is just going to smash right into the end of the rail when it's trying to throw super high. So I am hoping that that will be solvable with just a bit more tuning, but we may need to kind of limit the throw height if we need to. I'm hoping that with careful tuning, that problem should go away. And that is one of the things that I want to be able to experiment with on this robot, because I am pretty confident I'm going to be a lot more okay with breaking this robot than I am with actual Jugglebot. I really, really don't want to break anything on Jugglebot, but I'm hoping that this will give me a kind of like test platform to try some more things out with. Yes, so one other big thing that I want to mention here before we go up to the next stage is that I've also, because the stroke of the hand is so much smaller than it is on Jugglebot, we don't need to be coiling as much string around the spool as we do on Jugglebot's arm or hand. So I've made this spool a little bit shorter. I would like to make it even shorter again, but unfortunately there's not a whole lot of space in here left anymore. It's because this string passes through this hole in the spool, we need to be able to actually fit the string in there. And for better or worse, the shaft of the motor is fairly long. And even as it is right now, we only have 1 millimeter between the end of the motor shaft and this thing here for the string to fit through. Thankfully, the string is 0.8 millimeters diameter, so it should be okay. And it can handle a bit of squish. But yeah, unfortunately, I can't really go much shorter than this. And yeah, you'll see in a sec why it will be better if I can make this even shorter again, particularly on the right-hand side. Yeah, okay. The one last thing that I want to mention before we move up, well, actually two things. One of them is that I am very torn about what encoders to use in this sub-project. This is one of the things that I want to experiment with and learn from while doing this, because so far I've got like one encoder type on all of Jugglebot's legs, and that works fine and that is easy to use, but that's like a physical it's something that like mounts onto the shaft of the motors, and even with Jugglebot's legs that do not move very quickly at all, For one of the legs, it seems like it's possible. John is suggesting that the encoder might be slipping, and that's why you may remember from a couple of weeks ago, I was complaining that one of the legs was like tired all the time and was just misbehaving. John is suggesting that this problem could be caused by the encoder slipping on the shaft. And if the encoder is slipping on the leg shaft with such small movement, such like not aggressive accelerations, I really don't want to rely on that sort of encoder for like really fast moving motors like what the hand will be in here. Yeah, I've got more to say about encoders, but I think it actually might make some more sense to say in a sec. So on the hand here, I was originally thinking of using this magnetic encoder that I have on hand. I bought this 3 years ago, apparently. But I just have not been able to get these to work. This is where I got stuck probably like 6 weeks ago. Last time I mentioned working on this like ball Butler project is that I was just stuck getting these encoders to work. Like I have these motors, which you'll see in the CAD soon. These nice, like they look so cool, but I've never been able to get these to spin because the encoders that I was trying to use, I'm fairly sure are just broken. I honestly have no idea what's wrong with them. They are these little AS5047P magnetic encoders. I have looked up my purchase order for these and it turns out I got them from AliExpress, so I'm just kind of convinced that it's a dodgy batch and that they just don't work. I've spent too many hours trying to mess around with those and it's really... no. I'm not using those anymore. Yes, so there is another type of those, however, that I am considering using. It's basically the same footprint, but slightly different schematic. It basically sends the signals out over a different interface. So I'm considering using that. I like how small this magnetic encoder is. However, it would be simpler. Like this encoder and this motor would then need to send both of their wires down to the O-drive controller that would do the controlling. And for the hand of this system, I'm going to be using an O-drive Pro, the same as what I'm using on the current hand. So it looks like that. And in the spirit of trying to keep this all as small as possible, I was thinking I would use this small encoder here because it's nice and compact, and then I would run the cables from the encoder and the motor all the way down to the O-drive Pro, where it would then do the controlling. And because this is only moving, well, you'll see in a sec how large of a range of motion this has, but it's not that much, so I'm not really worried about the cables tangling or anything. But as we move up through the system, you'll see how little space we actually have here on the other sections. So I'm actually considering now just mounting the O-drive straight on there. Come on. Oh, it's suppressed. Like this. This mount is obviously not correct. I would need to redesign the mount to fit this, but it actually fits better than I was expecting it to. So I'm considering changing over to be like this. We would still need to route cables up to the O-drive, particularly for power and commands, like communication. But it would mean that the O-drive wouldn't need to be mounted somewhere else. So yeah, keep that in mind. Looking at comments, a human, nice alias, says, I saw a video the other day, Chris Bowden, I think, that showed how some elevators use a single linear strip of barcode-like sequences. Would it be practical to paint alternating white and black lines that create a unique sequence along the string, use it as an optical sensor? Yes, to detect the sequence. Yes, okay, that's a very good point, and I am very glad that you mentioned that, a human. Thank you. That's very good. Okay, so yeah, I mentioned before that one of the goals that I have for this side quest is to try things that I have learned about during the development of Jugglebot, but haven't yet had a chance to actually use on Jugglebot because I just haven't gone in this direction. And like those are decisions that you have to make a bit earlier on. One of those things is the possibility of using a linear encoder similar to like what my calipers use. Like this is I believe it's capacitive encoder in here that allows this to get an absolute reading of its position no matter where you move it. And you can move it like really fast and it will still be accurate as far as I can tell. The context of this in the normal Jugglebot work would be in redesigning the linear actuators. So that way the linear actuators get like real-time actual feedback of how long they actually are. I had honestly, I had not considered using that here. But we could. That's a very good option. Yeah, I'll have a think about it. It might be tricky to fit everything in here. There's not a lot of space to mount anything else. So your specific suggestion of using black and white strips to create a unique sequence, I wonder how well that would work. I think I'll check out that video. If you could send me the link to that video, or I'll see if I can find it later on. That sounds very good. I'm curious to know how well that would work for longer lengths and how precise it would actually be. I get the impression that capacitive linear sensors are quite reliable because I believe that's what my calipers use, and those are quite good. But yeah, I'm open to suggestions. So something that's worth keeping in mind is I really want to not mount anything. Ideally, I want to not mount anything at all to the linear slider, but that's probably going to be difficult if we're trying to measure its position. But I definitely want to mount as little as possible. I want to mount no electronics onto the hand, because that means that if we do mount electronics, that means we're going to have a cable running to this part that's going to be zipping around very, very, very quickly. And that's just a recipe for the cable causing problems. Getting caught on something, getting snagged and ripping out, or just like general wear and tear on all the joints. Obviously, we need good strain relief, but yeah. Very good idea. I'll keep that in mind. Yeah. So the other thing that you may notice here is how weird the hand looks. So we can see that it's very oblique off to the side here, to the point where I think it actually might be pretty impossible to put this screw in. So we may just have to go 3 screws for the hand. We could, of course, just drill out a hole. Well, not drill, but like put a hole in there so that I can get my bit all the way through. But I don't like the look of that. I did that at one point, but just having a hole through the hand here just looks crap. So I think 3 screws should be fine. So we'll see how it goes. If it becomes a problem, then I'll put the hole in. But yeah, so that's the hand. I think it looks good, and I think it should work pretty well. I'm pretty happy with that. So let's move up to the next stage. So now we can move the hand up and down and also rotate it in like a pitch kind of motion. Also, by the way, if you want to check out the CAD for this model, it's in a link in the description, and yeah, you can do whatever you want with it. Whoever copied this before is giving me a thumbs up. That's good. I like my likes. But yeah, you can do whatever you want with it. It's yours. Yeah, nice. Thank you for that video. I will definitely check that out later. It seems very interesting. Okay, so let's have a look at this stage without the hand actuator in it. The general idea here is that we are using a Capstan drive, or again, this will be like a semi-Capstan drive because I'm expecting to just fasten the string straight onto the spool here, just because why not? Like, that means the slipping is not a problem. Yes, so we'll have a string that will run from this little hole down here, up, around the spool a bunch of times, over the other side, and then down through this hole in here. To tension this string, because having the string be tensioned is fairly important, I'm going to use these little ratchet spools. This is something that I have used in the past, and I am very happy with how well it works. It's kind of surprising how solid this is. So I've got a little demo here to show you of a prototype that I made just to check that this would all work fine. So we've got the ratchet in here. You also actually, just before I show this, you'll notice that the ratchet has these 3 holes in it here. These holes are for rotating it, because as it is right now, like, you can't, especially because it's embedded in there, you can't like get your fingers in there to turn it around. So what I'm planning on doing is making a tool that basically has 3 M3 bolts sticking out of it, and then I can plug that in, tension it around, and then just remove it again afterwards. It'll be a nice clean resulting part. Come on, change camera. And yes, as proof that this works, I don't have that tool printed yet, but I can show you kind of sketchily with my hex driver. So let me put this in here and make sure I turn it the correct way. But yeah, you can see as I rotate this around, let's get the camera in focus. As I rotate this around, all of the teeth kind of snap over. And like, it's a pretty aggressive snap, like. But it really holds that position. So now I can pull on this string as hard as I want, and that's not going to slip. Like, you'd have to snap, what is that, all like 8 or 10 or something of those arms, and that's not going to happen. In the past, when I've used these, I have had individual prongs break, but the whole thing has still worked fine. And like this, I mean, I've rotated this quite a few times already, but let's keep going. Like, yeah, it's fine. It doesn't really like being tensioned that way. The bolts are a bit wonky now after having done that, but yeah, it works. Of course, there's a limit on how much you can do this because the string is going to spool up and eventually become too physically large in the spot where it can spool around here. But yeah, for small tensionings, it should work very, very nicely. Now, one problem with the model that is currently here is that the string that passes, it will wrap around the spool a bunch, pass through this little hole here, and that hole, let's go translucent. Also, if anyone knows a shortcut to do this translucent thing, I would love to know. I cannot, it doesn't seem like there is a shortcut to be able to do that, and it is very frustrating. So yeah, the string passes through this little hole here, that passes through all the plastic, and then should be perfectly tangential to the spool part of our ratchet, and that will allow us to tension up. The reason why I think that this could potentially be a problem, especially if we need to do lots of tensioning, is that that string is probably going to cut into the plastic a little bit, especially if I have that step there. I'm gonna delete that, make it a bit more smooth. So if the string cuts into that plastic, then like if it cuts in really far, then it's just going to end up like slicing through the plastic and yeah, going all the way through. I don't think that would happen. I'm hoping that this is just not going to be an issue because we're not going to have to tension that much. So it's just going to be like maybe like 5 centimeters tops of movement over the top of that, and it should be fine. Initially, and you might have noticed in the version that I showed before, this prototype, I had pulleys in there on either side to try to mitigate against this so that the string kind of rolls nice and smoothly. But getting those pulleys lined up was so tricky to do. So I can show you, there's an earlier version of this. Here we go, with these pulleys. I found it very, very, very difficult to get these pulleys in the correct spot. This is very similar to the problem that I had with the linear actuators a while ago, where, well, yeah, with this version of the actuators, where I claimed in the video that having 3 pulleys between the rotation of the motor and the linear movement of the actuator was necessary, but I was very quickly made aware of the fact that 3 pulleys is absolutely not necessary and you can actually do it just with 2. Along those lines, I feel fairly sure that this is possible with just 1 pulley to go from this. How do I want this to go? Let's go this way. I feel pretty sure that going from this spool out over the side, because it has to be over the side so that the string wraps and unwraps nicely, out over the side and then over this spool, I feel like that should be possible with 1 pulley, but I just could not position it correctly. You can see as it is right now, that is nicely lined up with the ratchet spool, but it's not at all nicely lined up with this spool over here. Like the string's going completely the wrong direction. And yeah, it was very, very difficult to get that lined up, especially because Onshape doesn't allow you to do 3D sketches. I found that very limiting here. I don't think I have a link in the description for this version of the model, but I'll include one after the stream ends, and you're more than welcome to make a copy and try it out yourself and see if you can get it to work. This part is main ring, if you want to see how I've done this. Yes. A human says, side thought, if the optical approach does have legs, you could use a fiber optic to bring the optosensor down from the arms, but still get location info from any point you want to read and collect it. I'm not sure specifically what you're referring to here. Are you talking about for this thing or for Jugglebot? Fiber optic to bring the optosensor down from the arms. I like how that sounds. All right, so let's return back to the main thing to continue talking about this. So yes, we've got the string in. The string is nice and tensioned. It is wrapped around this spool. And that means that when this motor spins, to give you context for like what part of this motor actually moves as well, it's a little bit tricky to see, but on the back there is this little hexagon bit. That hexagon spins with the motor, and the only thing that doesn't spin is this like gold plate on the back here with the wires coming out. Everything else on this will rotate. So the outside part and the top will all rotate. I'll get to your comment, human, in a sec. I want to reread that. So, yes, the string wraps around the spool, and then when the motor spins, it will allow the whole thing to move up and down. Now, I've put fairly conservative limits on how far this can move right now, just artificially with the mate limits, but it should, in principle, be able to go like the whole way down to the bottom. The reason why I've put those limits on is because when the hand is right down the very bottom, I don't want it to I don't want it to go past this plane here. We might actually be able to get it to go a little bit further down than this once we see what the next stage looks like, but for now, I just want to play it safe and keep it this low. And I really, like, this angle is pretty dang steep, so I feel pretty good that this will be able to throw to anywhere where I want Jugglebot, where I want Ball Butler to be able to throw to, so I'm not too concerned about pushing it further than this. It can also go completely straight up, and when it's straight up, there's still a little bit of room here for the string to sit, so it's not going to be like running up against physical limits. We have a cutout in here so that the bolt heads, we can see how tight this all is, and this is why I would like to make this string spool here a little bit smaller, is to be able to get this part over to the left a little bit more. But I don't know, making this cutout is not too bad. That kind of works. And of course that means that no matter where this isn't going to hit. And the reason why I've got the cutout so big is because you may remember that to tension the hand string on the bottom side, we will need to move this whole hand motor assembly. All of this will need to move up the extrusion. So I've cleared out a bit more space in there so that way that bolt head should never hit. And of course we can only go so far before we hit this guy. And this guy, there's so many little bits on this. It took quite a while to get this all to work. This guy is what allows us to attach the stage 2 motor, this guy, to the hand itself. Because, oops, let's get rid of this. Ultimately, the only reason why this motor is here is to be able to rotate this assembly. So we need some way to link the motion of the right-hand side here to the left-hand side. The way that I have decided to do this is by making this spool. I'm hoping that I'll be able to get my sponsor, JLC 3DP, to manufacture this out of aluminium for me. I think that should be pretty dang nice, because this is going to be a very load-bearing part. Like, it's going to be spinning, and also it's the only thing that's transferring torque from this right-hand side to the left-hand side. So that has to be pretty strong. On the end of that will be 2 bearings that you can see here. And then those bearings will sit in this printed part here. That printed part, in principle, it could be attached with a bolt on this side that goes into the aluminium, like that goes into a T-nut in the aluminium extrusion here, and then another bolt here that goes into the aluminium extrusion here. But if I did that, then that creates very difficult problems with how to actually physically manufacture this thing, because this bolt down the bottom is always going to be blocked by the ring. You might think, haha, we can just push it further than that. But by the time this whole assembly is put together, the string is going to be tight and it's going to be wrapped around the spool here, so we're not going to be able to actually go further back than this, or like a smidgen further, but it's never going to be unblocked from the ring. So we can't actually access that bolt in there once it's all together. So to allow us to actually physically assemble this, I will, for the first time ever, which I'm not super happy about, but I don't know, I can't see any other way to do it, I'm going to have to drill through the aluminium extrusion. So let's look at this view. So this bracket on the other side is basically just there to hold these 2 bolts and to kind of line them up. On this one, I'm going to put whatever, I think this was M5. I'm going to put M5 inserts, threaded inserts, into the plastic here, so it should be nice and strong. And yeah, we just got to drill straight through and put these bolts through. For a quick tangent on my use of Onshape, The reason why these bolts are so damn long, because they don't really need to be, and I'm going to cut these down with my angle grinder. The reason why they're so long in the model is because the way that I made my fasteners library was just so stupid, and I'm like kind of committed to it so much now that I'm kind of afraid to change it, because all of my models that I've made, all of the Jugglebot stuff uses these fasteners from this document library, and if I change it, then I'm worried that everything's going to break, and I'm going to have to spend like 2 hours just like fixing all of my fasteners. The stupid way that I did this is to basically have configurations for every single size of different types of bolts. So I've got the button head over here, we've got cap head on this one, and we've got shoulder bolts in here as well. This means that if I want a different length, I have to make a specific configuration for it, and then fill in the table all of its different values. And we can see like all of these guys are M5. So like 90% of their measurements are exactly the same. The only thing that's different is the length. So a much better way to do this, if anyone is curious about setting up their own fastener library, is you can add a configuration variable. And this allows you to set things dynamically. So we can do, let's say the default is 10, the minimum is, I don't know, let's make it 5, maximum is like a meter. Then that variable pops up the top here, and now you can reference that as like an equation. So I don't know, let's go in here and make this length. Now I can just type in a value in here, and I get that length. How good's that? But the problem for me is that if I do this, I'm going to have to change all of my fasteners in like every single thing that I've done. So I'm very, I don't know, anxious to actually change that properly. What is going on there? But yeah, strong recommend if you're using Onshape and you're setting up a fastener library, use configuration variables, not configurations, because otherwise you end up with a super messy table like this. No good. But yes, these will be cut down and they will not be sticking out like that. Okay, so let's continue on. And yeah, so you can see here, this is with the O drive on the hand like that. And like, it's not, like it's obviously bulky, but it's not really in the way of anything. So I think the savings that are to be gained by using the small encoder are not really that great. Potentially, because it's just more hassle. And we know that the O drive works with its... The reason why this works, by the way, with the O drive here is because the O drive has an onboard encoder. This little chip here is its own magnetic encoder, which is basically the same thing as this one, but just on the O drive itself. Yes. What else to say about this? I've got two other things, I think. The first is that to get all of this spaced nicely, I have bearings in here. So we've got like 2 bearings on both sides, and these are just normal radial bearings. They should only really be encountering radial forces, so I'm not really worried about using like thrust bearings or anything like that. And I've spent quite a long time thinking about how to attach this onto, how to attach like these swiveling parts onto the main ring. And I'm hopeful that this will be strong enough, because there's only really, what is this? Like here to here, 17 millimeters. I believe it's the same on both sides. Yeah. So 17 millimeters on both sides, holding each of those in. I think that should be fine. I was considering for a little bit using longer shoulder bolts and then having them stick out a bit further on, like in this case, on the left-hand side, and then having those be supported by the next stage. But I kind of feel like this should be strong enough. But to be able to get these spaced out nicely, I have the 3D printed part touching the inner race of the bearing. So that way, it should be exactly where it needs to be, and there should be no rubbing between the moving part of the bearing, which is the outer race, and the plastic parts. There should be no friction at all. The only parts that are being contacted on the bearings are the inner races on the shoulder bolt side and on the printed side, and then on the outside, the whole thing will be fine to rotate. That presented a big, one kind of major problem, which is that to be able to print these cone shapes on both sides to be able to touch the inner race, it makes it very difficult to print that main ring. So if we isolate this, like this looks so good to be printed in this orientation, right? Like it's perfectly flat except for this little nubbin here. Except for that, it's so good. Like all of the features that you would normally need to support are on the top side. So like this cutout here, this longer nubbin bit, all on the top side. The only other issue that I can see with printing it this way is that this ratchet groove thing will probably need support, but I'm not really that worried about that. Now that I've moved to the new 3D printer, I've become a lot less concerned with printing with no supports. So I'm kind of a bit more happy to just use supports when necessary. But I don't want to have to support this entire face here just because this bit's sticking out. Like that seems like a bit of a waste. So what I've done to solve that was actually inspired by another Functional Print Friday video. I quite enjoy his videos. I've been watching a few of them lately. And the general idea here is that we can print this in two separate parts. So we can print, I don't know, you can kind of see how this is, actually let's go into here. Once this loads. Let's go back before we merge them. So we can basically print the main part like this, and this should print perfectly fine, I think. I may need to chamfer this hole, but we'll see how we go, or just support it. But yeah, this should print fine, and then as a separate print, we can print this little nubbin this way around. And then we should be able to insert the plug part into the main part, use a pretty good amount of super glue to just get that real stuck in there, and that should be completely fine. So I'm hopeful that this will work and not need supports, which would be nice. Or not need to support that entire face, at least. Yeah. Looking at comments, a human says, instead of changing the existing entries, create a new one for variable length, then if when you want to... That's a good idea. Yeah, so he said, programming experience has taught me to leave things that have relationships well alone when trying a new methodology. Yes, that is a good point. I'm also aware that in Onshape, you can actually set things to be a specific version. So like this shoulder bolt is from that fastener library. But if we replace its instance, you can actually, where are we? Let's, standard parts, fasteners. What order is this in? It's not alphabetic, but I don't know. It's just so random. It makes it really hard to find stuff. Yes, so we have shoulder bolts, and yeah, so you can like look through the version graph and like pick a specific version of a part that you want, but it warns you that it's not the most recent versions. Like if I pick, what have we got? Shoulder bolt. I don't remember what size this is, but let's say it's this one. If I pick that version, then it tells me, hey, you can update this, and like you should update this. So if you specifically pick a version like deliberately and you want it to stay as a particular version from the like reference library, it's still like, hey, update me, and all it takes is one time to forget that you specifically chose that version for then the whole thing to crash. But I do like your idea of adding it as like an additional thing. I think that's a good idea. Yeah, so yeah, this is stage 2 and I feel pretty good about this. Part of me was a little bit concerned that this part won't be strong enough, and especially if the stage 2 motor moves really aggressively, that's going to make some weird torsional forces in here. But I'm hopeful that the stiffness of this arm and the stiffness of this mechanism on the left hand side, and like the size of these bearings, I'm hopeful that those will be strong enough to resist that, and also that this part will be strong enough to actually transmit that torsion. We'll see. In any event, this motor should not be pushing that hard. Like I'm going to try to make sure that this moves kind of slowly to not be too aggressive, because it doesn't really need to be that aggressive. All right. Now this is where one of the big potential learning experiences will come from. So something that I have been aware of for some time, but haven't had a chance to actually test out yet, is the idea of, if you have a gearbox on your motor or some way of basically have your motor's output, you're modifying your motor's output in some fashion, and then that modified output is what's actually driving your motion. Everything that I've done so far, I've only been tracking the motion of the motor itself. I've never been tracking the output of whatever modification I'm doing. So like if I, for example, with the linear stuff, like the hand motor spins, I'm tracking the position of the hand motor extremely precisely, but I'm not actually tracking the linear motion of the hand at all. I'm just kind of relying on that kinematic chain being tight. And it may or may not be, depending on how loose the string is. In a similar fashion here, we have the motor is spinning, and because this is geared down by quite a bit, like this diameter is 10 and this is 150 millimeters radius, so that's what, like a 30-to-1-ish ratio, then, if I've done my math right, then this motor will be spinning quite a lot for the whole arm mechanism to only be moving a little bit. And if the strings are not quite tight, or if there's other problems in the system, then it's possible that if I command this motor to move by a certain amount to get the tilt to be correct, then the end result will not actually be there because the string's too loose or whatever. So I'm kind of thinking that this might be a good opportunity to use a second encoder on the actuated, like per motor, basically, except for the hand. Maybe. So my thinking here is that we would have an encoder on the motor itself, so that way we know exactly where the motor is. But then a second encoder somewhere down here. I've been having a little bit of a think about this, and the way that I've set this up, it's a little bit difficult to fit something in, but I think it will be possible without too much work. To chuck in another encoder down the bottom here, and that way we can get accurate readings for the motor position itself relative to its start point, and then also we can know the exact angle of the entire mechanism. So that way if they ever deviate at all, we can know immediately that they've deviated, and we can still control the absolute angle precisely. In addition to all of this, because this range of motion is well and truly less than 360 degrees, it should be possible to use an absolute encoder, which is another thing that I've heard a lot about, but haven't had a chance to use. These encoders should, I've never used one, but as far as I can tell, they are designed to remember their position even when you power them off. So that way you don't need to go through any homing sequences. And the reason why this would be great for this is that I wouldn't need to do any limit switch business or anything like that. I can just have the encoder on here, and as long as I don't touch it, like as long as I don't physically move the mounting of the encoder around, like I should, when the whole thing's powered off, I should be able to move this around, and the encoder will still be able to figure out exactly where it is within 360 degrees. And so we'll know as soon as we power on, yep, the motor is exactly at whatever angle this is, 60 degrees, we'll say. And I really like that idea. I really like not needing to home the robots. I don't like homing. Homing is just slow, it's tedious, it gives opportunities for the homing sequence to be slightly different every single time. Like with the limit switches, maybe the position that the switch switches over is going to be slightly different as like the little lever arm bends over time, or maybe the mounting of the limit switch is like slowly shifting. It just gives opportunities for things to go wrong. And it's also slow and tedious, and I don't like doing slow and tedious things all the time. So yeah, interested to hear your thoughts on that. I'm hopeful that this can work and should be a good investigation into using these more in the future. A human says, I very much appreciate this Onshape walkthrough and observations. Nice, I'm glad. This is great as I haven't got a CAD experience yet. Cool, yeah, I definitely recommend Onshape. It's free. Like, if you haven't already, you can click on the links in the description, and they should all just, like, you don't even need to sign in. You can just open the link, and then you can see the model that I have here, and you can, like, move it around. Yeah, see, I've experimented a little bit with, like, opening it with, like, as, like, a non-user, or not, like, signed in, but I haven't done that too much. I hate the white screen, and yeah, it's... You should have access to like all of the feature tree and everything. So yeah, definitely have a poke around. Onshape is really good. I definitely recommend it. And I'm not even sponsored. So there you go. Yeah, so what else on this? Ah, yes. For the hand motor, I'm planning on using an ODrive Pro because I have one that's not needed. However, I'm planning on using a different ODrive for this motor and for the third motor, but yeah, I think I'll explain that in just a sec. So I think that's everything on this stage. Now let's go up to the last stage, the base. And you can see that I have clearly reached a kind of stopping point with how detailed I have gone in my modeling. I spend a large part of my working time on Jugglebot working on just this, like stage 1 and stage 2 to get this all nice. And I haven't really done much on the base since the version that I showed a little while ago. So the general idea here is, this is identical to what I showed a couple weeks ago. So if you've already seen that, then you know what I'm talking about. But my little sketch here should give you an impression of how this works. So we've got the motor it's here in the middle. We've got belts that fasten, like one will be fixed on this end, one will be fixed on this end. And then as the motor spins, it will act to bring those belts closer to one side or closer to the other side. And that should make the whole thing spin around. Now, the belts will be rubbing on like this part of the plastic, so I'm planning on putting down some of this tape. I've got ultra high molecular weight tape, which is extremely slippery, and I'm hopeful that that will mean that the belts should be able to slide over it pretty easily, I hope. We'll see. And then so those will be fastened somewhere at the back, so that way this should be able to get pretty much 360 degrees of rotation. Now, of course, because this is going to be mounted on that shelf behind me, it doesn't actually have, like, I don't really want it to be able to rotate to face this way, especially because if it does, then this is going to smack into the wall. So I don't really love that. But yeah, again, because this base part will have a slightly less than 360 degrees of rotation, we should be able to use an absolute encoder on this as well, like have a second encoder. So we'll have the one encoder on the back here, similar to what I've got in this CAD, and then a second encoder on the actual base itself so that we know absolutely exactly where it is. So once we power on this system, like say it's been off for a little while, we power it on, the base should know exactly where it is straight away. The stage 2 should know exactly where it is straight away. And the only thing that we'll need to home is the hand. So we can basically just bring up stage 2 so it's vertical, so the hand doesn't hit anything. Bring the hand down until the current limit spikes, which is a mechanism that has worked flawlessly in the probably like hundreds of times that I've done it on Jugglebot, so I'm really not worried about doing that. Brings it down, current spikes, we know that we're at the bottom, and then we know exactly where everything is. The one potential problem that I could have is if the stage 2 is not actually vertical and the hand like hits the base and then thinks that it's at the bottom, maybe, but yeah, I don't think that'll really be an issue. There is, of course, still a lot of CAD work to be done here. Like the base needs to be mounted on top of something so it's not just sliding on the desk. I mean, that bolt is sticking through the desk. That's not ideal. Yeah, this is not like fitted into the base here correctly at all. There's a lot of work to be done, but this is the general idea of what I'm imagining it will look like. Now, I mentioned before that I'm using ODrive Pro to control the hand motor, but I'm using a different ODrive to control these two. For that, I'm planning on using the Butler V0 3.6, and I have, I think, 4 of these from the early Jugglebot days. These are not recommended for new devices anymore. ODrive still sells them, but they're really suggesting you don't use them. The reason why I want to use it here is because this one board can control 2 motors, compared to this board, which is, I don't know, maybe a bit bigger than half the size, can only control 1 board. And also I just kind of want to use the old ODrives because currently they're just sitting in a box collecting dust. So yeah, I want to fit that in, but of course, because there's not very much space here, I don't really know if that can actually fit. So I may need to have like a chamber underneath, oh, let me go back to the CAD. I may need to have a chamber underneath this so that all of the electronics and like the second ODrive can fit inside there somewhere. Yeah. So that's the general idea. Let me see in my notes if I missed anything. Yeah, nice, cool. We're good. So there's one other option that I was thinking of. Instead of using absolute encoders, I was thinking as a different way of doing position sensing. The mechanism that I've been doing so far has either always been limit switches or sensing a current spike. So the actuator will run until it hits some physical limit. It obviously runs very slowly until it hits that physical limit. And then once it hits that limit, the current in the motor will spike, and we detect that spike and we say, yep, we are probably where we should be. How well that is, how reliable that is, yeah, it's reliable enough for me so far. However, there's another option for doing that I have only just recently become properly made aware of, which is using a proximity sensor like this one, where we have, I believe, oh, it's inductive. Okay, there you go. So it uses some sort of inductive sensor in here to detect when it's near a metal object. So you can, and it will detect it before it makes contact, importantly. I believe you can get different sensitivities of these, and you can play around with like different types of materials, and they will detect from further away or closer. But the general idea is that you can detect proximity without having to make contact, which is very nice. And I'm thinking that that could be, like, that's something that I'm interested to try, but haven't had a chance to do yet. So I'm considering using that instead of the absolute encoders, so that way it will home, but it won't actually have to make physical contact. But yeah, I'm kind of leaning towards the absolute encoders because I think that's a much neater solution for this problem. Yes. So there's a couple other things that are important for this that I haven't mentioned yet. And actually, just before I get to those, doing this, and this might be useful for you, a human. I don't know if this is a common experience for people when they are CADing things, but it absolutely is for me, where if I let's say that, to use an example from here, there was a stage when the main ring was, was like this. It had it just came to a corner, and that's all it was. And so there was no way to mount, oh, it's a composite, all right. There was no way to actually like mount these parts. These shoulder bolts were basically just mounted to, they were like mated to these points down here, which of course doesn't work in reality. And I was just sitting there staring at this for so long, and I don't know how to describe this feeling other than like, I don't know, like a pit of despair. But it's a very common feeling for me where if I am like designing a new part that has to interface with other parts, I'm like, how can this shape exist? But of course, like once you do it, it's like, well, obviously, like this is how it fits, and like it fits perfectly. It's good. But before that point, there's that moment of like, what do I do here? Like, yeah, it's such a not pleasant feeling, and I really don't like it. For reference, the way that I overcome that feeling is just to start, just do it, and then just like be as crude as you want to be, and then refine it later. With most CAD things, if you have like a reference object that you're trying to copy, copying it is like super easy, usually, unless there's like fancy surfacing or lofting and stuff. But for most things, like copying an idea is very, very straightforward, but coming up with it initially can be quite challenging. And most of the time, I find my crude solution just ends up being the actual solution. I don't even need to like redo anything. It just works. But yeah, I'm kind of wondering if part of the reason why I am feeling this way is because I don't really do enough like concept sketches of the whole thing beforehand. And if I did those concept sketches beforehand of like what I want the overall shape of the thing to look like, then maybe that would give me more of like a reference to copy from for each specific part. But it's tricky. It's tricky. So the reason why I'm bringing that up is because I don't have like reference drawings to show you of what I'm imagining this thing looks like. I just kind of like have an image in my head of what this could look like. So with that in mind, let's talk about some things that I haven't implemented in the CAD yet. The biggest thing is that this is fine for throwing balls out, but we can't get new balls in, right? That's a pretty big problem. In the same way that I don't want to be manually reloading Jugglebot, I certainly do not want to be manually reloading Ball Butler. So my thinking here is that there will be like a hopper next to Jugglebot that will just be full of balls. And then to get the balls into the hand, I haven't CAD'd this or drawn anything, so you're just going to have to use your imagination with me as I describe it. Let's go to the camera. The idea of the mechanism that I'm thinking of using was very inspired by the new printer that I have, the H2D, where for the nozzle cleaning process that it goes through, there's like a part that moves in and out. There's like the nozzle head, and then there's a part that moves in and out that's separate to the nozzle head, and there's another part that is separate to the nozzle head that moves up and down. And I was very confused by how these worked originally. I thought they were motorized and it was just timed to be in sync. But it turns out that it's completely mechanical. So the nozzle head, the like extruder part, will bump into like a little lever, and when it bumps that lever, it will move that part in and out. Or when it bumps into the other lever or pushes it down, it will lift the other part up and down. And I really like that idea. It's so simple. It's just like a mechanical lever. That's it. You just bump into the lever and it does the thing because it's mechanical. There's no circuitry, there's no motors that can do the wrong thing, there's no programming, which was so nice. Yeah, very simple. So I'm thinking of doing a similar thing here, where I want to basically make a lever where one end of the lever is like a little scoop. Now, getting the hopper to only funnel in one ball at a time into the hoop might be a little bit of a problem, but hopefully I'll be able to get some inspiration from Wintergarten's work with funneling all of his little marbles around. I feel like that's a pretty solved problem. So there'll be like a little cup, and then once something over here, so let's say that it might want to like rotate to a specific point and then raise the hand up. Oh my god, this is so tedious to move around sometimes. Let's say that the arm, like this stage 2 goes completely straight, and then, for example, the hand will move down, and there might be like a little lever sticking out over the side here, somewhere where this will not ever need to go to actually throw the balls. The hand goes down, pushes that lever, and then the little scooper plops the ball in. I think that will be very elegant, and that should mean that to reload and throw, it basically just like rotates around, moves down, gets plonked a new ball, rotates to where it needs to go, throw. Rotate around, plonk a new ball, rotate, throw. So it should have a pretty quick refresh time. Obviously depends on how tight all of this is made, but I feel like that should work. I'm hopeful. That's my intention, at least, for that. Yeah, and there's plenty of space up there on that shelf for a nice big hopper, so we should be able to fill it up with quite a few balls. Pretty cool. A human says, pro tip, proximity sensors come in PNP and NPN. I think they tend to be used as end stops, which makes me think they can only pick up a millimeter or so of proximity. I think it really depends on the material that you're sensing. So how I became aware of these just recently, I think I knew about them a while ago, but I just kind of forgot about them. But what reminded me of them just recently was there was a Jeremy Fielding video, I believe his most recent video. I'll put a link in the description once the stream ends. There's a video where he just talks about different tools you can use to automate things. And I'll make sure that the link that I put is like timestamped to this point because it's a pretty long video. But he shows it sensing like a steel bolt and an aluminium plate. And the steel bolt looked like it was probably about 5 millimeters away, maybe up to a centimeter. But the aluminium plate was like, as you're saying, like right next to it. So I think it depends a lot on the material you use. Yeah. And a human also says, also relating deeply to the well, it seems to be working fine, method of developing. Yeah. It's dangerous though. You can, yeah. Like that's what my fasteners are now. So my fastener library that I've got was working fine, but now I've had to, I just recently bought a whole bunch more fasteners, so I have more on hand, so I need to update my library. And as I was updating these, I was like, oh god, this is terrible. I hate this. I hate every bit of this, while I was just filling it out. And then when I was done, I was like, cool, I don't need to touch that anymore until I add in the rest of the fasteners that I bought, because I don't want to do it right now because it's such a pain in the ass. It's like it works, but it doesn't really work. Yeah. And a human also says, the Butler could return to a loading position and a well-aligned feed tube could dispense a single ball that falls into the cup and settles on its own. Yes, I'm glad you mentioned that. So something that I quite like about the mechanism that I described is that all of the balls will be able to sit fairly low down because there's going to be a lever that will lift the ball up and put it into the hand. The balls will be able to sit fairly low. I just for like, I don't know, aesthetics and also for the purposes of me putting the balls in, like that shelf's not super low. I mean, I am kind of tall, but I can definitely reach over, but it would be nicer if the balls could be as low as possible. So I want to avoid having the reloading system have to be above the lowest point of the hand. In my mind, the feeding tube and having anything that like drops the ball in, that will need to be above. But you are right, that would be a lot simpler. And you could basically do the same thing where there could be like a structure over to the right over here where this rotates around and then, I don't know, maybe the O drive bumps into a little lever and that opens up little gates that like drop a little ball down or drop the ball down. That could definitely work. But I really want to try to have the balls as low as possible in the hopper or not need to be above the hand. But that is I can definitely modify that requirement. Yep. Yes. So much stuffing around with encoders this week. I did not like that at all. I'm so confused about how I managed to do some things in the past, but like didn't keep a good record of it, so I don't really know what I did and whether or not it even worked. So much stuffing around. But I feel pretty good that this can come along, that this will work. I know that this will take some time, and I'm still a little bit, I'm like 95% committed to just like getting this done and putting aside all the Jugglebot stuff. But then I still have so much Jugglebot stuff to do. Like this is, looking fairly objectively, like this is a bit of a random time to be doing this because Jugglebot's not really at the stage where it's dropping all the time because it's not throwing all the time. Like it's just starting to get to the point where I'm getting it to throw independently. And this is a bit of a random time in that regard, but I don't know. And there's like, I've still got so many notes on like, from like the stream 2 weeks ago, of like all these suggestions that people made. I'm like, yes, I should do this, and this, and I plan to, but I really don't think there's ever going to be a clear point where it's like, okay, Jugglebot is good. There's no more things that need immediate attention. I really don't think that's going to happen. So now it's a good time to work on Ball Butler. I feel like if I try to wait for that moment, I'm never going to get it done. And I really do want this to be done, partially for feeding into Jugglebot so I don't need to do it myself. But the main motivation for me doing this is to get my personal Ball Butler working. I despise bending over. It kills me. It ruins me. It takes me out of the zone. It just destroys my sessions. I hate it. And I really, really, really want something that can just give the balls back to me. Yep. So I'm very motivated, but like there's just Jugglebot stuff that should be done. So it's a tricky decision to make. And a human says, makes a lot of sense to keep the amount of physical stuff in the playing field to be minimum. Yeah, I want it to be as simple as possible, but also like it has to be of a certain level of complexity to be able to work at all. So yeah, I don't know. I'm torn. Very torn. Yep. Okay. There is one other thing. Oh, actually, no, two other things that I want to mention. So I have mentioned a few times so far that a big goal of going down this rabbit hole is to put into practice some things that I have learned about and actually get some experience with them so that I know how they work. One of those big things for me is using batteries as a form of power. I have been a little bit terrified of using batteries, to be honest. Lots of people have suggested using them for various parts of Jugglebot over the last couple of years, but I've always been a little bit too spooked by them. They kind of give me the heebie-jeebies, and I'm worried that I'm going to like electrocute myself or break some expensive electronic equipment by using them. However, I'm kind of aware that fear is a little bit unwarranted and like it's probably not that dangerous, or like if I'm careful, I feel like I probably won't break anything. So I'm kind of thinking this might be a good opportunity to use batteries to power this mechanism, or maybe if we want to get real fancy, have it be battery powered or powered by the mains. Because I could run a power cable up to that shelf, but it'd be good if I didn't need to. I will need to get some kind of communication up there from Jugglebot so that the ball butler knows when to throw in. I think that'll be very handy. So if I'm running like a communication cable up, like I may as well run power as well. But yeah, I think this potentially could be a good opportunity to introduce batteries into my toolkit. Maybe. Yep. The other thing that I want to mention is something that I am so frustrated by, and if someone knows geometry better than I do, I would love to know how to do this. So the problem, this is very different to everything I've been talking about so far. The problem is that I have these motion capture cameras, and they track these little dots. So you can see on the end here, there's these little gray dots. These are retroreflective markers. Basically, the cameras shoot out infrared light. Infrared light bounces off of these retroreflective reflectors straight back to the camera, and then the camera can see each of these dots as a circle, and then using that and the 4 cameras, the whole system can figure out in 3D space where each of these dots is. The problem is that the motion capture software that I'm using you can basically tell it, hey, I have a rigid body here. This body is always going to be the same. I'm never going to bend it around. So all of these markers are always going to be in the exact same spot relative to each other. I can basically take a sample recording of me with this in view of all of the cameras, and then say, these 5 markers in this configuration is this rigid body. But the problem is, if you pick a silly orientation, like let's say that we only had these 3 markers around the ring here. If those 3 markers were the 3 that I was using to define this rigid body, it wouldn't know if this is the orientation at any given time, or if it's this, or if it's this, right? Because there's only 3, you can rotate it around and it will look exactly the same, but the handle will be sticking out differently, but the cameras can't see the handle, so they don't know where it is. So they can only fit those 3 markers. So you need to put the markers in a spot that is unambiguous and can only be fitted in one particular way. Now, something that I've been thinking about a lot during this process is the fact that the calibration tool that they give you to like calibrate the cameras and to basically set your workspace looks like this, where you have a big L shape. These are all, I believe they're all perfectly planar, so they're all in the exact same plane. The distance between, there's a very particular like rule about how far these distances are. I believe this distance has to be less than this distance, has to be less than like there to there, or like this corner to the very end. And this works. Every time that I've tried this, it's always unambiguously, it knows exactly where this L is. It knows exactly where each of these markers are, and it's not going to mix it up and get them wrong. So I'm thinking that maybe that's the way to just like always do unambiguous things. Even with this. So you may remember the old catching cone that I was using had all of the markers being coplanar. The 3 were very similar to the 3 that I have on the new one. However, I also had 1 down here and like basically 2 near the handle. And this is pretty close to unambiguous, but I only realized after having printed it out that if we mirror it around this line here, it's very close to being the same on both sides. Like this distance is slightly bigger than this distance, but not by very much. So if the cameras get a little bit confused and they flip things around, then it's like, well, the fitting in this orientation fits really nicely, but also the fitting in like this orientation also fits pretty nicely. So it tended to get a bit confused sometimes. And I was like, okay, cool. I can fix that by just moving 2 of these markers out of the plane with all of the rest of them. And that way there'll be a distinct, like we can't flip it, because before it was flipping it this way. It was flipping it like about this axis here. But if we have markers out of the plane, then it will set that flip a lot more distinctly, which is what I did in the new version. So now we have this one is slightly lower than like the plane the rest of them on, and this one is also kind of like in between. But it doesn't work. it does work most of the time, but the problem is that if the cameras only see 4 of the markers, then it can get, it somehow gets confused still. I can set in the motion capture software how far, like how long each of these segments can be off of what the calibration was. So in the calibration, it might say this distance is 6 centimeters, this distance is 6 centimeters, this distance is 2 centimeters, etc., etc. And basically it keeps like a mapping of how far apart they all are. You can set in the system how much error that is allowed to have, which should, like if I bring that allowable error right down, it should mean that it can only ever fit it in the correct way. But even with lowering that quite a bit, it still, every now and then, it will still, if it can only see like 3 or 4 of the markers, I mean, obviously, if you can only see these 3, then there's only so much it can do. But even if it can see one of these side ones, it still flips it around and gets it wrong. And I'm so confused how to make a rigid body with markers. Like, surely there is a way to put a finite number of markers on the object so that you can hide any number of those markers and still have an unambiguous fitting of that rigid body. Surely that's possible. But I've got no idea how to do it, and my brain just can't handle the geometry. It's yeah, I tried making it, you may remember a little while ago, I tried making a Python script that would kind of do this for me, that would like test a bunch of different orientations and see if it fits, but that wasn't working perfectly. And to be honest, the fact that the motion capture software doesn't come with the ability to do this, like I would have thought if this was possible, then they would have a feature in there where you can try putting in different configurations of markers and it would tell you how likely it is that that will become unambiguous or become ambiguous. But the fact that they don't have that in there maybe kind of makes me think that this problem's a little bit harder than I think it is. But it's so frustrating. I just want my catching cone to be tracked properly. And also, I don't want to have like 15 markers on here because the more markers I have, the slower it is to track it, essentially. Yep. A human says, for what it's worth, there are 3D prints and commercial parts to adapt power tool batteries. Yes, so you can clip them into your own project. Yeah, I've seen those things, and I'm interested in them. Yeah. Yeah. I like that idea. Because I've got some... Ozito is the cheapo Australian brand for these sorts of things. I've got a lot of Ozito batteries that yeah, I am using, but I don't know if I'll be using forever. I hope to eventually upgrade to the Ryobi Club or Makita or something nice, but it's definitely out of my budget for now. Yeah. Yeah, that is a possibility. That's a good idea. Yep. Okay. That's a lot of ranting. Yep. There will not be a stream next week either. Doing these streams really makes me realize how often I'm away on Fridays. It's really more common than I would have thought. But yeah, next week I've got a family gathering. We do one every year on the King's birthday long weekend. So I'm keen to spend some time with my family who I haven't seen properly in a little while. So that'll be nice. And yes, I didn't check my calendar for the week after. Let me check it quickly now. I'm pretty sure there will be a stream the week after. So in 2 weeks from now. And hopefully we will have some cool developments on the hand. Yes, there should be a stream in 2 weeks. Yeah. Hopefully I'll continue with... I expect to continue with the ball butler. I really, really, really want this to be done. But there's a few problems. Like I definitely need to flesh out the design a lot more, especially with the base part. And I'm curious to know as well. So to give you some context here with how I designed this, I started off with this second stage part because I knew roughly what the hand stage was going to look like because I have already done that on Jugglebot using like John's design for the hand. And I know that works, and I knew that I was going to stick with something similar to that. I didn't know if I wanted the hand to be on this side or on the side over here, which has advantages because it means that like the hand won't smack into the ground when it's down the bottom, but it makes it a bit more difficult to route the strings around so that we can still do things like attach onto this side and yeah, use like the center hole of the extrusion. So I knew roughly what the hand was going to look like. So I started off with the main ring and like this part of the actuation, and then once that was looking pretty good, I did the hand stage, like designing all of these like little parts down the bottom and the motor mount and everything, and then putting this together. And now I'm up to the point of getting the base done. So yeah, I don't know if it would have worked a bit better to go from the base in rather than like the hand out. I'm not sure, but this seems to be working all right. I'm definitely in my mind, I am absolutely the whole way through this thinking about how this will fit into the rest of everything else. So yeah, you can't really just stick with one level and just design for that, because then you realize that it's going to conflict with something else. But I think this should work. I feel good about it. And I'm very keen to be printing some big bits. I have not really had much of a need to print big parts on the new printer, and I'm keen to print some big bits because I like holding big bits. It's very satisfying. Yep. Cool. Okay, that's everything. I hope you found that interesting, and I hope you see my reasoning for diverging from the main Jugglebot project for what could possibly be some time. I definitely hope that this will be done by the end of the year. But yeah, it's hard to know how long it will take, because everything should be nice and clean. I know how to set up a CAN bus now. Finally, I know how to set up all the O drives. There's a couple new things that I want to include in this so that I can learn about them, but I think this will be a good exercise to see how far I've actually come. Yeah, but we'll see how we go. We'll see. All right. Yep. I hope you found that interesting. There's links for all of this stuff in the description. Actually, there's one other thing that I would absolutely be remiss if I didn't mention, which is that the inspiration for this Capstan drive, like this rolling the spool over this ring part as a way to move this up and down. The inspiration for that came from an Aaed Musa video, who's I didn't include a link in the description originally, but I will at the end of this stream once we're over. But his design was very, very useful to reference against, and he made that design public, so I have a copy of it in here, and this is in the Onshape model as well. So if you want to check this out, you can see it in the description, in the link in the description. And his design was a bit different. This is actually this is a step, so it can't actually move, but yeah, a bit different. He uses much thicker string than I'm planning on using. I don't feel that that's necessary for what I'm doing. I think the thin string I'm using is fine. And his tensioning mechanism was a bit janky, in my opinion. I think my ratchet thing is much cleaner. But the general idea is very, very inspired by his design. It's a very tidy design for what he was doing. It's quite cool. So yeah, definitely recommend checking out his video if you're curious about this. Yes, I'll get it done before the end of a year. Yes, I like that phrasing. Oh, I didn't even have the CAD on. Oh, so this is Aaed Musa's one. Yeah, so yeah, bit of a different design. And yes, if you want to check that out in the Onshape model, it's in CAD imports, Aaed Musa test stand. Cool. All right. I hope you found that interesting. And yes, please give me suggestions if you have any. Particularly at this stage of this project, a lot is open and able to be changed. I haven't printed off anything for any of this yet, so except for this little test part, which doesn't really count. So yeah, things can definitely be changed. I really like a human's idea of putting a linear encoder on the hand. I'm kind of skeptical that anything will be able to work at the speeds that we need here. So the hand will be traveling at a max of about 5 meters per second, and that's pretty fast, with an acceleration of like, I don't even remember what it was. I think it was like, I only did it in revolutions. It was like 1,000 or maybe 10,000 revolutions per second squared. I can't quite remember. But very, very, very fast accelerations. So whatever we add onto there, if we do add that linear encoding stage, it would need to be working with that speed. But I'm very curious to check out the video that a human was suggesting. I love your name. It's so good. Yes. So give feedback. Feedback is good. Hopefully it will stop me from going down stupid rabbit holes or going down stupid dead ends that I don't realize are dead ends right now. And yeah, cool. I will see you in 2 weeks. Until then, have a good one.